All right, so I'm going to make a couple of videos on vectors. Vectors are really used in physics and will be used in calculus, but not to the level of calc that you would take here at Orange. If you continue calc in college, you'll see vectors again. If you take physics, definitely see them again. So just going over, we do very basic vectors applications and operations. So first, what is a vector? So things like length, mass, volume, they all just have a number attached. So we call those just a scalar. But vectors are quantities that have a scalar, but also a direction attached. Velocity, force, torque, displacement. So a good example I can give to you is speed is a scalar. How fast you're going, it has no direction attached. But if we're talking about the velocity, that has your speed, which is your scalar, but also has a direction attached. Geometrically, a vector is technically a directed line segment. So if you can think back to probably middle school when you learned like line segment, ray, all of that, where this does get a little confusing is a line segment means it has a start point and an end point. And that is what a vector has. It has an attached length to it. That is the scalar portion. But it looks like a ray when you draw it, meaning it's going to look like it has an endpoint and an arrow. And the reason for that is because it has a direction attached, the part that has the arrow is telling us what direction it's moving in. So it's telling us where it starts and where it stops. A line segment doesn't really need a start and a stop. They're interchangeable because it doesn't have a direction. These need a direction. That's what makes them a vector. So it does look like a ray, but it does have a definite start and stop point. That's probably the most confusing thing about vectors. Only the magnitude and the direction matter. When I say magnitude, that is talking about that scalar. Only that matters. The position does not matter. So that means I can pick a vector up and I can move it around. And you'll see that in some of our problems in our operations. And because of that, because vectors can be moved around, you can have an infinite amount of vectors that are all the same vector. When you see a vector written, it is either written by a lowercase bold letter, but if it's not typed, then we can't bold a letter. So you'll see it written as whatever the letter is with an arrow on top. Sometimes people will get lazy with this and they will only do a half arrow. Still means it's a vector. Okay? So let's do a couple of operations with these real quick. So here's our first example. It's just drawing a vector. So directed line segment JG has an initial point J and a terminal point G. So we call the initial point the tail. Sometimes you'll hear people say, draw your vectors like tip to tail or head to tail. We call the initial point the tail and the terminal point the head. When you draw this out, we don't know right now anything about the direction of JG, but wherever the initial point is, that actually looks like a point. And wherever the arrow is, that is G, that's the head. So initial or the tail, whatever you want to call it, has a dot. Terminal or the head, that has the arrow. It tells us what direction it's going in, okay? The only other thing here we didn't talk about already is this. So we've mentioned up here, that vectors have a scalar and that scalar is talking about, usually like the length or whatever. And this is just the notation for it. So when we talk about the length of a vector, another word for that is magnitude. And the notation for that looks like absolute value. So it puts the vector inside of these absolute value bars. Let's say that they called this vector, so up here they didn't give it a name. They just told us the start and the stop point. Let's say this had been called vector U. then we would write this as the magnitude of vector u. That's how you would see it. And that would mean that they want the length or the magnitude of that vector, okay, which we're going to learn how to find here in a few minutes. Okay. Standard position of a vector is the most convenient way to write a vector, and that's because it's the easiest. We can pick a vector up and move it wherever we want. So it's easiest for us to pick that vector up and let it start at the origin. Let it start at 0, 0. So that's what standard position is. It is writing the vector with the initial point or the tail at the origin. Okay. And that is moving it into standard position. When we do that, we can write our vector in what's called component form. Okay, so same thing, it's the initial point 0, 0. A vector in component form will be written in not with parentheses, but with these like less than, greater than symbols on either side. And inside will be the terminal point. We don't need to write the initial point because if we're writing it in component form, it is understood that the initial point is 0, 0. So let's practice putting one vector into component form or moving it to standard position. It gives you a little formula here if you wanted to do it algebraically. And the formula is just take the terminal point and subtract the initial point, and that will put it in component form. So let's do that first with this problem, and then we're going to pick it up and actually move it on a graph so you can see whichever way is easier for you that it comes out to be the same. So if we did this with no graph, terminal minus initial, here's my terminal point, here's my initial point. To put it in component form, terminal x minus initial x, terminal y minus initial y. So the component form of vector v is -2, -2. And what that means, if I'm given a vector in component form, it means that it starts at 0, 0, that's the initial, and it goes in the direction and ends at the point -2, -2. So it goes from the initial to the terminal point, and that is the vector. Now, what I've been talking about is that vector could have been anywhere, but this is going to be what it looks like. This is the length, this is the angle or the slope that, that all the vectors of this, all vector v's will have. So let's draw this out, just so you can see. So I'm going to draw -3, 4. And -5, 2. So you have to also remember here that I drew this, I didn't use graph paper. So it does look like this vector is longer, but you can also see that I scaled a little differently on my two graphs. But what we mean by we can pick a vector up and move it is we picked this vector up and we just moved it here. And that's what we did to get the component form. So it's the same vector, it has the same length or magnitude, it has the same slope, but the position can change. You can pick it up and move it. So I don't know of anyone that would rather do it this way. Most people do terminal minus initial to put it in component form, but you could think about, graphing it and like moving it here. I think it would be harder, but that's what you're doing. The math in doing it is just terminal point minus the initial point to move it. Okay. All right. Next thing we're going to look at is, actually, I'm going to stop here and make a new video for finding the magnitude of a vector.